different way. Here we go. All right, so here we go. So part 2, really it is what we did yesterday, but we're going to kind of emphasize a little bit more domain and range and things of that nature. So this is graph the parent function and transformed function by writing the transformations, graphing the vertex, axis of symmetry, slopes of the lines, and domain, range, and interval notation. So if you look at this first one, example 1, the parent function is f of x equals absolute value of x. So if I have g of x equals the absolute value of x minus 1 plus 2, how has this one shifted? Remember, vacuum off and in socks only. The vertex is the opposite of the inside, same as the outside. So how is it shifted? Anybody want to try it? Yeah.
Is it up 1 down, or up 1 right 2?
Is it right 1 up 2?
Yeah, right 1 up 2. So what that means is the vertex is 1, 2. The axis of symmetry is x equals 1. My slope will be 1 and negative 1. And the reason why it's 1 is the a value is 1. The a acts like the slope. So watch what we're going to do. We're going to plot the vertex 1, 2. Does this one open up or down? Up. Okay, it opens up because the a value, even though I don't see a number, it is implied to be 1. So I'm going to go up 1, right 1, up 1, right 1. Do at least 2 points on each side. Then you go up 1, left 1, up 1, left 1. Please fill the grid. Okay, go till it touches. Don't make a teeny tiny B. The domain of all absolute value functions will be negative infinity to infinity. The range are the y values. So Chris, can you help me out? What is the lowest y value on the grid? 2. And then it goes up, right? So we're going to do bracket 2 to infinity. So again, vacuum off and in socks only. The vertex is the opposite of the inside, same as the outside. The inside is the left, right. The outside is the up, down. And yesterday we explored. Remember, we made tables, and then you did that for homework. Yeah, Hannah?
So the range,
Yes.
is that just for the first,
Okay, the range are the y values. So this has a stopping point, right? So it's the lowest y value was 2, and then it went 3, 4, 5, 6, 7 to infinity. Okay? All right, so let's try example 2. What if I have g of x is 2 times the absolute value of x? Does anybody remember from yesterday? What does a 2 times do? How did we describe it? Yeah, Julia?
does it shrink?
You're on the right track. It's a stretch. Okay? It's a stretch of 2. Okay? When the number, the a value is bigger than 1, it's a stretch. When it's between 0 and 1, it's a shrink. If there's a negative, you treat the negative like differently than the number. The negative is a reflection. So my vertex, okay, the vertex is if you have a left, right, up, down. So my vertex is 0, 0. The axis of symmetry is x equals 0. And then the slopes would be 2 and negative 2. I do the domain and range after I've plotted it. So I'm going to put 0, 0. This opens up. So you go up 2, right 1, up 2, right 1. And then do it on the other side. And here's where the axis of symmetry is coming in. And fill the grid. So the domain is always negative infinity to infinity for an absolute value graph. All Cameron, what would be the range then?
Is it bracket 2 to infinity, or is it 0?
Okay, well, you tell me. What's the lowest y value?
0.
0. So it's going to go bracket 0 to infinity. All right, when you're ready, flip it over. Example 3. G of x is negative 1/3 absolute value of x. So, what's the transformation? I see two things. Luke, you want to try it? What are the two things we have as the transformation? What's the negative do for us? Okay, it does make the slope negative, but in terms of description, the 1/3 is a shrink, okay? So the 1/3 is a shrink of 1/3, but what does the negative do? Anybody? It makes it go down, and the mathematical term we use is reflection. So don't put opens down or flip, because that's not mathematical, okay? We're going to use proper mathematical language. So it's a reflection. The vertex, there's no left, right, up, down. So it's 0, 0. The axis of symmetry. Can you guys check your papers carefully and make sure you don't put just equals 0 or a 0. It has to be an equation. It's a vertical line. 0 doesn't describe a vertical line. The slopes of the line would be negative 1/3 and 1/3. So this one's going to open down. Okay, this one's going to open down. So here we go. 0, 0, and I go down 1, right 3. Down 1, right 3. And again, fill your grid. Make sure it's not a U shape. Okay, make sure it's not a U shape. Yeah, Hannah?
This domain always going to be negative infinity to infinity?
Yes, the domain for absolute value will always be negative infinity to infinity. That won't change for absolute value. All right, so Alex, can you try for me the range on this one?
0, bracket 0 to negative infinity.
You are really close. We always put the smaller thing first, so I'm going to flip that. Do you see that? It actually starts negative infinity and comes up. So you always go the smaller value to the larger value. All right, try example 4. I'm going to pause, and I want you to try this. See how much of it you can do on your own. Anybody have the transformations? There are two things. Yeah, Julia?
Reflection and left 3.
Awesome. Reflection and left 3. So what would the vertex be, George, if I move it left?
Negative 0.
Awesome. Negative 3, 0. So then my axis of symmetry is negative 3. And then, Jesse, what are the slopes of the two parts?
3 negative.
Nope. The slope is the number out front. Delaney?
Would it be negative 1 and 1?
Negative 1 and 1. Okay, do you see it's the number out front? So here we go. Negative 3, 0. And David, does this one open, this B open up or down?
Down.
Okay, good. And you might want to make yourself a little note, you know, before you even get started. And then when you're done, look back at your note and say, uh-oh, I made mine go up and it was actually down. You can like catch some silly mistakes. All right, then I go down one, right one, down one, right one. Use the axis of symmetry to hit the other side. Okay, so we are using the axis of symmetry. So the domain is negative infinity to infinity. Now look back at example 3. It's very similar in example 4. So Brooke, what would be the range here in interval notation?
-3 infinity.
Okay, we're going to put the smaller value first. Do you see it's coming, it goes down forever. So that's going to be negative infinity. And then, okay, I see where you're getting your -3 from, but range are y values. What's the y value when x is -3? 0, okay? So this is going to go negative infinity, comma, 0. All right, last one. Example 5. All I'm asking you is to describe the transformation. We're not going to sketch it. So I'm going to pause, and I want you guys to try A and B. In A, you should have 3 things, and in B, you should have 2 things. All right, Theron, what'd you say for letter A? What were your 3 things? Okay, do you, looking back at, even on this side, what did the negative do? What math word did we use for a negative out front? Do you see right here we had a negative? It's a reflection, okay? That's a reflection. Then it's the opposite of the inside. So, Julia, what does the x plus 2 tell us?
Left 2.
That's left 2. And then safe, what does the -3 tell us?
Down 3.
Good, down 3. All right, letter B, g of x equals 1/2, absolute value x minus 5. So, Ellie, what does the 1/2 tell us? Good, that's a shrink. That's a shrink of 1/2. And then Hannah, what do you think the x minus 5 is telling us?
Right 5.
Awesome, right 5. All right, what I'd like you to do now is I would like you to go grab a marker board.